Hello everyone, here is my presentation for IBM Advanced Data Science certification. My topic is predeterminated environment and adapted loss function for derivative trading. From my agenda, and the first place, I will introduce my use case. And the second part, I will give you a review about my predetermined environment. And the third part, I will define the adapted loss function for trading. And in the fourth part, I will show you some result and deliveries. From the fifth part, those are the presentations for stakeholder, some kind of summary of the risk, and also some more explanation in general. And the last is loss function, and also show you some result. Let's start. In trading area, there are 4 standard processes: data gathering process, decision process, execution process, and maintenance process. In this project, I focused on data gathering process and decision process. My goal is to predict the price movements up to next 4 hours. This page shows you the predetermined environment, focus on price prediction of movements. First of all, I download the original data from Ducat's copy, open, high, low, close, and also the value. I choose the oil against the dollar 1 hour data, and I decided to use close price as movement indicators. Then I decomposed the signal, use Wavelet, and put them together to support vector regression, and use the RBFcan as default. And I predicted the prediction value of subsignal and reconstruct the subsignals together and use the last one as prediction value for the movement. The whole result is about 10,000 hours in the last 2 years. And the predicted values are saved with the CS4 file, and the JSON format will save the metadata in together. The data looks like the table from this page. We got the time, open, high, low, and the value. The high shift 1 is price movements of the high price with regarding the last 1 hour. The predicted value from support vector regression using last 2 days input, and then we give them to Python code. I defined the basic element, the period of the models, and decompose the signal, prepare the input for support vector regression, and get the prediction value, put them together, and saved and CS4 file. And for next step, you can see the result for the next 1, 2, 3, or 4 hours are just the probabilities, and we can use much more complicated models to improve those results. To improve to the enhancement of the baseline, I decided to do some experiments using XGBoost, long short, term short, non-network, and also my own adapted loss function level 1 and adapted loss function level 2. The XGBoost, I just use the default parameters and update the model every 24 hours to simulate the practice. I use the default binary loss function for long short-term memory neural network to predict the next 2-hour press validation. And I changed the loss function to add 3 major functionalities. The first one is multi-time windows, which means non-fixed time window such as next 2 hour or 1 hour, just up to next 4 hour. And the second functionality is capital allocation, which means if we invest 100 euro in the next 4 hour, which one would be the best choice? Which one has the best probability to get profit from the market? That's a capital allocation problem. And the third one is trade or not, which means if the market is risky, then the AI should decide to do nothing to avoid the loss in the market. The model structure here is the long short-term memory neural network. All the 3 are almost the same. We have 3 hidden layer, 1 long short-term memory cell, 2 densities, and just 1 output. The XGBoost, just a default build, and update will be every 24 hours in our simulation. This is the performance comparison. In total, we trained the model using more than 9,000 hours data in the past 2 years, and the baseline Wavelet and support vector regression modules gave us just around 40% accuracy, which would be very bad in the trading purpose, in our trading process. And this baseline is improved by XGBoost from 13% accuracy to 52% accuracy. And then I used long short-term memory with binary loss function to produce next 2-hour predictions. The accuracy is also improved, but not so much, and not better than XGBoost, just from 40 to 48%. The adapted loss function level 1 gave us good improvement from 40% to 50%, and the level 2 loss function gives us the best solution from 50% to 64%, which can be used in the trading market for good profit. And in this table, I listed all my Jupyter notebook links. You can get more in details information from the link. And from this part, from this page, is for stakeholders, some kind of high-level summaries and risk analysis. The first page is all about the definition of the use case, focus on data gathering and the decision-making process, and also my goal is to predict the price movement up to next 4 hours. The data size. The most risks came from our broker. If our API connection works not so well, and we got a very large delay, and then the data quality would be very bad. The volume is a big issue because non-broker in the market could offer the high accuracy number of value in forex trading, and the total risk of the data gathering process comes from the broker, not from local, not from the model, not from the indicators, but from the broker. The solutions, I built 5 different models, actually 6. Wavelet, support vector regression, XGBoost, binary long short-term memory, and 2 different adapter loss functions. I spent about 1 week in predicted environment, 1 week for XGBoost, 1 day for XGBoost, 2 days for binary long short-term LSTM, and 2 weeks for adapted loss function. You can see the accuracy, it's just a hit. And if my prediction classification was correct, then just count for 1. From my experiments, the best solution comes from the adapted loss function level 2. The baseline is support vector regression. It just give me around 50% accuracy from the whole test. It's just some kind of random guess. It's not so good. LSTM with binary loss function give me not so good solution. I will never use binary LSTM for treating purpose. That would be funny. That's why I changed the loss function. About the predeterminated environment for treating, I used the wavelet to decompose the signal, open, high, low, close, and the value, and use the support vector regression to produce the forecasting value of the subsignal, and then I reconstruct the wavelet for you and use the last element for the prediction value. That is very simple as predicting the environment. And I also analyze the importance of weak predictions. And you can see the prediction value of close price based on the last 3 hours has the most important value, F1 value. And the second level is our value prediction based on the last week. We got different importance of our futures. The most important one, the two, close price and the value. This picture shows us the comparison, the performance comparison of XGBoost. XGBoost improves the baseline from 40% to 52%, which is very large. The improvement is very good, but the final result, 50%, cannot be used for the trading purpose because it's just a little better than random guess. The final trading profit would be not very large or just negative because of the fee from the broker. Then I changed the loss function for trading execution. The original loss function, binary loss function of LSTM is just the decision about sell or buy for the next 1 or 2 or 3 or 4 hours, but the fixed time window. That would be not very practical. Then I add 2 functionalities to loss function. The first one is multi-time windows functionality and the capital allocation functionality. The multi-time window, which means the prediction value is not just for 1 hour for next fixed time window, but for up to next 4 hours, which means the next 3 hours could be the best investment per choice, or the next 1 hour would be the best choice, and the capital allocation will give the corresponding weight for the best choice. If the next 3 hours would be the best one, then the weight of the invested money would be much more than the rest one. But the market is still risky. If the market is risky, the AI should decide to do nothing to avoid the loss in the market, which I added the third functionality to the loss function, which has a name, do nothing, or you can call it holding option. It's also would be fine. And in the level 2, the loss function has 3 major functionalities: sell or buy, multi-time windows, capital allocation, 4 major functionalities. Capital allocation and do nothing if the market is risky. That's very important for the trading purpose, because if too risky, the best option is do nothing. Do not invest anything in the market. That's very important. From the experiments, the LSTM with binary loss function give me just 58% accuracy, which means this kind of loss function should not be used for the trading purpose unless you have best data in the world. Because the balance of the information, if you have much more advantage of the information than the others, then you can use the binary loss function without any adaptation or changes. But if you don't have the best data in the world, my advice is do not use the original loss function for the trading purpose. Then I changed the level 1, give me 55%, which is also very acceptable for the trading purpose, but it's just fine. The level 2 give me 64% accuracy. This one is very good, which means I can definitely use this for the trading purpose. The level 1 and level 2 are my own inventions. Here again is the performance comparison. The level 2 give me the best solution and the best return from the market, and you can see from the yellow line, it's just stable and also reliable, and the profit is positive compared with the baseline of support vector regression, which give me the negative return of about 500 500 euros minus 500 users, and the level 1 give me around 50 bucks, 50 euro, and the level 2 give me also the 50 euro, but much more reliable, much more stable. Again, this table contains all my work in the last 3 weeks. It's very complicated, and you can get much more information from the links. And thank you guys. And again, about myself, I have a master of mathematics. I have 10 years experiences in data science. I focus on applying AI for industry and also financial trading. And if you have any questions in derivative trading, about AI trading robot, about anything about trading, you can write me an email or just visit my homepage and also my LinkedIn profile. Thank you very much. Enjoy the time.